Okay, here's another Alex problem with our thermochemistry. A chemical reaction takes place inside a flask submerged in a water bath. The water bath contains 7.50 kilograms of water, probably going to have to change that to grams, at 34.7 degrees C. During the reaction, 121 kilojoules of heat flows out of the bath and into the flask. So if heat goes out of the bath, that means that it's getting colder, and into the flask, that means the flask is getting warmer. Calculate the new temperature of the water bath. Alright, so the water bath starts out at 34.7 and heat goes out of the bath. That means that number is going to be lower than 34.7. Gives us a specific heat capacity here. Alright, we can probably tackle this particular problem. So let's do it. We know that heat Q equals the specific heat capacity times mass times a change in temperature. Okay, so we're going to have to figure out what that change in temperature is. How much is that 34.7 going to cool down? Okay, so let's rearrange that. So delta T equals Q divided by the specific heat capacity times the mass. The specific heat capacity is given in joules per gram per degree Kelvin. Again, the magnitude of Kelvin and Celsius are the same in terms of the change. And so let's go ahead and convert 121 kilojoules. So 121 kilojoules, I need that in joules, and I know that in 1 kilojoule there are 1,000 joules. And so if I do that math, I know I have 121,000 joules. Okay, that's going to be my Q with 3 sig figs. Specific heat capacity is given right there. The mass, 7.50 kilograms of water. Again, it has to be in grams, so let's just hurry and convert that. 7.50 kilograms. That's one you might be able to do in your head, but I'll just do it this way. I know that in 1 kilogram there are 1,000 grams, and so my mass in grams is going to be 7,500 grams. Okay, I can bring that over to my problem now. So delta T equals Q, which is 120,000 joules, divided by the specific heat capacity, which is 4.18 joules per gram per degree Kelvin, okay, times the mass, which is 7,500 grams. Okay, so if I do that math, then I have delta T that's going to equal 3.8596. Okay, and that is going to be degrees Celsius, and since it's a delta T, it'll work for degrees Kelvin as well. Okay, so that water, we know it's cooling. Okay, we know that it's cooling, so it's 34.7 minus 3.8596. I know where my sig figs are going to land me, and so when I do that, I get 30.84. Okay, so I'll keep my sig figs. So the new temperature of the bath, the answer to this problem, is going to be 30.8 degrees C. That should be the temperature of the water bath after this reaction is done.